Okay, so today's lesson we're doing scale diagrams. So scale diagrams, where might have we heard of scale diagrams before?
On scale?
On a scale? On a diagram, nice. So where do we see scale diagrams?
Nah.
Who is in who's in outdoor ed? Who's in Mr. Kim's outdoor ed class? Brennan is.
Yeah.
Did you do a scale diagram at the school? The map?
I did first semester.
Yeah. Okay. So what did you do, Logan?
We went around and just got a general outlook of the school, where all the rooms were and such.
Did you measure anything?
Not really.
No, you just kind of winged it a little bit.
Yeah, it was mostly a Google Earth sort of look, just trying to make it look as close as you can.
As possible, right? Yeah. You guys went out and you paced it, and then you drew your representations based on how many paces you have, right? So what you did, you took a really big image of the school, and because you obviously can't fit that on one piece of paper, right? You guys did a scale diagram of the school on a piece of paper, right? So you represented the school, but just at a much smaller scale, right? Same kind of thing if we look at that map over there, right beside Brennan. That is the scale representation, right? If you look,
every inch is 10 kilometers.
yeah, it will tell you what the scale is. So here's your scale up here. So we have one finger width is 100 kilometers. Okay, so that's a scale representation.
Some people have wider fingers than me.
Yeah, well, and whatever, you can measure that. It's probably 1 centimeter is 100 kilometers, right? Yeah, so these are scale diagrams for sure. Okay, so you guys have this. So example 1, you have a floor print right here, okay? So this is a scale representation of a living room or of a house, right? So we know in the house we have a 10-foot back wall, you got a 5-foot opening to the kitchen, you got a 4-foot opening to your balcony, right? You guys have the diagram, right? So obviously this right here is not 8 feet, right?
Yeah.
Yeah, so this is going to be a scale diagram, okay? So what is a scale diagram? We've talked about this a little bit. It is a reduced or enlarged copy of the original, right? It can't, you can go from the size of Canada onto a sheet of paper, or you can go from a microscope slide to a bigger piece of paper, right? So you can go from, you're either reducing it or you're enlarging it, okay? All of the dimensions have been increased or decreased by the same amount. Okay, you guys should be writing this down. Okay, just wherever, right here, maybe. Okay, and the original and the drawing are similar to one another. They're just scaled down, okay, or up, right? If you're doing a scale diagram of a cell, like in your bio class, you're going to be enlarging it. Or if you're doing a scale diagram of a house or a school, you're going to be reducing that size. Okay, so we are given this problem here, so we'll get to it we will be solving this. Okay, we're going to work on a scale for this couch, love seat, and wall unit into this floor plan that we have there, okay? So we'll just get those notes written down. So before we get going with our calculations, we need to ask ourselves, how do we find the scale or scale factor of a diagram? Okay, this is important, you guys. You need to write down these. Okay, so it is measurements of the diagram. Whoops, maybe I shouldn't, I tried to underline that. So measurement of the diagram divided by actual. Okay, so you can say diagram divided by actual. Okay, so that is important. So to find the scale, you're going to divide the measurement of the diagram by the measurement of the actual thing. Okay? When we are finding scale or scale factor, you always want to reduce the fraction to lowest terms. And more often than not, it will have a 1 in the numerator or the denominator. Okay? If you want to find like a scale percentage or a scale ratio or a scale decimal, you can. Okay? Fractions can be converted to percents or decimals or written as ratios. That is grade 7 math. So you guys should be good at that, right?
Where's Emery?
I saw him.
I watched him walk
Okay,
up.
okay,
I
okay.
saw him.
Okay, write this down, please.
I think he just goes with Jared every day.
Emery?
Yeah.
Oh, yeah. I heard Mr. O'Yell and Miss Lee's talking, and they're like, we're gonna have to do something about Emery not showing up to school. And they were
Just
talking
log-
about a bunch of
What can
people
they
that
do
themselves.
about that?
He's got.
Kick him out?
I don't know, that's-
It doesn't even matter, you dropped out
That's
last year.
admin's job.
Only
Okay.
pair of people.
You guys write this down? Let's focus on our own learning. Okay, it is essential that they are in the same units. Okay, you can't have like a meters per kilometer. Okay, you want like meters per meter. Okay, or kilometers per kilometer or centimeters per centimeter. Okay, that is essential. They must have the same units. So that's what you're gonna write in that little box. When finding the scale, we must have the same units.
Did he actually say he was gonna drop out there?
Yeah.
Alright, so we're going to answer some questions related to this floor plan again, okay? So you guys have it on your front piece of paper, right? And I have it on mine, okay? And then we don't have it on here. So what is the scale of the floor plan? So somebody remind me from the very front page, how do I calculate scale?
Scale is,
Reduced or enlarged copy of the original.
Yeah, but how do I calculate it?
Decimal correction.
The measurement of the diagram divided by the actual measurement.
and reduce the.
So I
fraction to
can-
lowest term.
If
Yeah.
I was gonna do like, say, like a diagram of a football field and I did like every like 10 yards is like 1 millimeter.
Yeah.
Okay, that would be the diagram.
Yeah, so your diagram would be like 1 millimeter, right? And then your actual would be the 10 yards,
Okay.
right? But then you would have to convert those either both to yards or both to millimeters to get that scale factor, okay? There are no units on scale factor, okay? That's why we need to have them in the same units, right?
Alright.
Okay, so it's diagram to actual, okay? So let's go back to here, okay? So the diagram, the actual is 8 feet, right? So let's try out a ruler. And let's see how big this actually is, okay? So, measuring that up, and I got, let's say, 2.4 centimeters on there, okay? So that's our actual measurement, it's 2.4 centimeters. Our actual, so the actual measurement is 8 feet, right? If we jump back, the wall is actually 8 feet, right? That's okay? And what did we get for our measurement? We had 2.4 is the diagram, okay? So 2.4 centimeters. And actually, I am going to measure this in inches because it's just going to make it a little bit easier, right? Inches and feet, right? So let's go, that's like 1 inch.
Yeah.
Okay, we'll call it 1 inch. And again, my ruler on here is a little bit different, right? But so 1 inches or 1 inch, right? So what do we have to do? Same units, right?
Yeah.
Same units. So
Just get inches and there's.
let's go feet to inches. How about?
Okay.
Okay? So if we want to go feet to inches, and feet is in my denominator right now, what's going to go in the numerator, my conversion factor?
12 inches.
Okay, we want our units to cancel, right? So if I have feet in my denominator here,
Oh, 1 foot.
yeah, good. So then we have 1 feet or 1 foot, whatever, right? And then how many inches are in 1 foot?
12.
12. Okay, so anything divided by itself is?
0.
Or itself.
1.
Okay, how many times do I have to ask that freaking question? Anything divided by itself is
Cancels
1.
it.
It cancels
It's a
out.
complicated question.
No, it is not.
So.
And I've asked the same question like 20 times this year. Okay, sorry for getting fired up about that, but oh my gosh. I'm so excited for the day when you say it's 1. That is
I don't know
gonna
if
be,
it's ever gonna come.
that's when I can finish.
I think I'm gonna keep saying 0.
Okay, Cody. Inches divided by inches. Anything divided by itself.
1.
1.
Doesn't count.
Those will cancel as well, right?
0.
Okay, so 1 over 8, and I had a different measurement, but that's okay. So we have 1 over 8 times 1 over 12. I need a scientific calculator for that. Okay, so we have 1 over 8 multiplied by 1 over 112. And then I'm going to turn that into a fraction. So I get 1 over 96 if you do that. 8 times 12 is 96, okay? So the scale is equal to 1 over 96. So what does that mean?
So, for every 96 inches, it's 1 foot, or doesn't make any sense.
No, okay, so our scale is 1/96th.
Oh, it's for every, so for like every like 1 actual size, we have 96.
Other way around.
Or for every 96 of the actual size, it's just 1 for the scale.
So our scale, so this image
It's
here,
96th size of.
times smaller,
Yeah.
right? Yeah, for sure, okay? So this scale diagram, or this, based on our measurement, it is 1/96th the size of actual, okay? Is that okay? Okay, good. So yeah, our scale is 1 over 96. Is this fully reduced?
Yeah.
Yeah, right? So we have a 1?
1, yeah.
Yeah, good. Okay, so our scale is 1 to 96. So let's hang on to that. Make sure you guys hang on to that. Okay, so draw the furniture in the floor plan. We don't need to do that, but I just want to find the scale for that, okay? So let's just calculate, we'll calculate the sizes, this to scale size of our images, okay? So, we'll do the couch, and you guys have these already, right? Couch, love seat, and the wall unit. Okay, so jump to the front page. What is, so these measurements are shown in the table below. So the couch is 40 inches by 90 inches.
Yeah.
Okay? The love seat,
40 by 66.
thank you. And the wall unit,
20 by 60.
okay? So, we know these 3 sizes, right? So, is what we have to do. Let's say that our width is going to be x. So, we'll do width by length, okay? Width, length, width, length. And we're going to let our width equal x. And our length is going to equal y. Okay? So, if we want to find the scale, right? This is the real size of that couch, right? We want to find the scale size for our little drawing, right?
Would you not just have to, would you not just go 40 divided by 96, 90 divided by 96?
Close. You're really close, okay? So for our width, okay? So for our width, we know it's going to be x over 40, okay? So our scale is what our scale size is going to be x. 40 is the actual measurement, and then that is going to equal 1 over 96. Okay? So then we're going to solve, we'll just cross multiply here. Okay? So 96 multiplied by x, 96x, right?
96, yeah.
And 40 multiplied by 1,
40.
40, good. Now, we'll divide both sides by 96 to isolate for x. X is equal to what?
96 divided by 96.
No, 40 divided by 96.
I'm gonna go with 0.48.
Close. I had 0.416. Yeah, so 0.417. And this will be in inches, right? Because we have inches here. This is inches, so these are going to be inches as well, okay? So, now we need to do the same thing for our y, okay? So what is the length of this couch?
90 inches.
90, so what am I going to write instead of x over 40?
X over 90, or I guess Y over 90.
Yep, perfect. And what's my scale factor?
40 over 96.
Careful. What's our scale factor?
40 over 40?
From last time, right? What did we calculate here?
It's the same. Oh, it's the same. Okay.
It's the same for the whole diagram, right?
Yeah, 1 over 96.
So 1 over 96. Okay, same thing. Cross multiply, right? So 96 times y
Yeah.
is what?
96 Y.
96y. 90 times 1? 90. Divide both sides by 96.
Then you have 90 divided by 96. Probably like 0.94.
0.94.
Yeah, I searched that off.
Oh, did you actually? Okay. I'm like, dude, that's really good. So yeah,
Not
0.938.
that good.
And inches, right? This is inches, okay? So, and then we'll just follow up and write our dimensions now, okay? So our width, 0.417 inches by 0.938 inches. Okay? Is that okay? Okay, so let's do the love seat next. You okay, Brody, if I move this?
Yeah, I'm arguing this one.
So the love seat. So let's look at our width. 40/40.
Yeah,
We've already found that, right?
yeah, 0.417.
Perfect. So x 417 inches. Okay. Now to find the y. So how am I gonna set up the y, Logan? Kind of like this, right?
Yeah, kind of like that.
So you tell me. How do I set it up?
So I would do y over 66
Good.
equals 1 over
What's our scale?
96.
Our scale factor, right? 1 over 96. Okay, so cross multiply, so we'll get 96y is equal to 66. Divide both sides by 96.
0.68.
Thank you. Is there 3 decimal places or is it just 2?
I think there was probably 3.
We'll just keep it consistent.
0.689. 0.688.
Okay, so now we'll just put those 2 numbers together. So the dimensions of the love seat, the measure, like the scale, the measurement, we have 0.417 inches by 0.688 inches. Frickin' Americans with their inches and feet.
They're stupid anyways.
Hey, be nice. But they are. Just kidding.
No, you're not.
I have some American cousins.
Oh.
So it's okay.
I do too, but I don't care.
And your sister's going down to America too, right?
She hasn't fully decided yet, but maybe. I think she's leaning towards it, yeah.
Okay, so do the wall unit on your own. Okay, so the width is 20, right?
Yeah.
So I'm gonna do x over 20 is equal to my scale factor, right?
96.
Over 1 over 96. So then you'll get 96x equals 20. Divided by 96,
96. 0.208.
0.208 inches, right? Logan, is that what you got or no?
I got like
I accidentally divided by
0.7.
60.
Divided by 60, oopsies, that's okay. Okay, and then we'll do the same thing, so we have y over 60 is equal to 1 over 96. Then we get 96y is equal to 60, divided by 96.
0.625.
Yeah, that's what I did.
Yeah,
Oh,
I got it right for the second part.
oh.
Okay, so then we'll just write those 2 numbers together.
How did I mess you up?
So we have 0.208 by 0.625.
I'm literally doing the math. I can't fucking
I don't care if you're doing
Okay, is that all good? So Logan, did you figure out your
Yeah.
error? Yeah.
I did the second part.
You okay, Brody?
Yeah.
Yeah, Cody? Good? Okay. Excellent. Okay, so in summary, if your diagram is a reduction of the original image, so if it's getting smaller, like we see on our map of Canada over there, if it's getting smaller, what types of scale factors would the diagram have as a fraction? What might that look like if it's getting smaller? What's going to be bigger? The numerator or the denominator? Yeah, perfect, okay? So denominator is larger than the numerator. Okay? And you will see 1 as the numerator, right? So for example there, I have 1 over 32. Or 1 over 96 is what you guys had, right? For your scale factors, so let's keep it with that. 1 over 96. Okay? So if our fraction, we have a larger denominator than a numerator, what is our decimal going to look like?
Few numbers.
Few numbers is going to be greater than 1 or less than 1? Less than 1, right? Good. So as a decimal, will be less, so a number will be less than 1. Okay? And for example,
0.0, what are we going to? 3 decimal points?
so 1 over 96 is what?
0.010.
0.0, like that? Sweet. Okay, so that's what your scale factor would look like as a decimal, Logan. Okay, as a percent, is it going to be greater than 100% or less than 100%?
Less than.
Good. Less than 100%. So for this one, if you're going from decimal to a percent, you just move it 2 spots to the right. So this would be a 1% scale factor. Okay, and as a ratio, yeah, I was just gonna tell you that one. The first number, or sorry, the second number is larger.
How would you convert that
What?
into a ratio?
You would use your fraction, 1. So if it's 1/96, it would become 1/96. Yeah. Okay, so go ahead and try to do the second half. It's kind of just the opposite of what we just talked about, just while you wait. I was talking already. Logan. You're done now?
You're the second half? Yeah.
Yeah. Then we can do this together. Okay, so if it's the opposite, if it's an enlargement of the original image, so we're getting bigger, right? What is our fraction going to look like?
The numerator is bigger than the denominator.
Nice, good. Numerator is greater than the denominator. Good. And our denominator will be 1. Okay, so this is for an example here. We might have 5 centimeters over 1 centimeters, which would be 5/1. As a decimal, greater than 0, nice. Or greater than 1, sorry. Number greater than 1, so 5/1 is going to be 5. As a percent,
Greater than 100%.
great.
500%.
Yep, good. Number greater than 100%. And again, that decimal's right here, so we can move 2 spots to the right. So then we got,
And then ratio, the first number's bigger.
yeah, excellent. Very good. Great. Okay, and then it'll be like diagram. The diagram measurement is getting bigger, right? And this is going to be your actual. Okay. How are we feeling about this stuff? Okay?
Yep.
Cool. So one example. Why is there so many on here? I don't know. Let's do this. So, this is an image of an animal cell. Okay, from your bio, right? You got your mitochondria. Shred it. Shred the glucose, right?
Yeah.
What else do you guys learn about in Bio 20? Mitochondria, cellular respiration, photosynthesis, right? That's kind of the big
and
ones.
we're learning about,
Digestive system.
Oh, cool. So you guys learn about enzymes and
And the
stuff?
heart.
yeah.
So secretion cells, so like, what's that called? Golgi apparatus? You
Yeah.
guys learn about that? Yeah. I don't think it's as much as like a cellular thing other than those two
Yeah.
topics, right? But yeah, bio's fun, right? Okay, so the diameter of the animal cell that is represented is actually 0.25 millimeters. So actual equals 0.25 millimeters. Okay, and the diagram is 3.5 centimeters. What is my formula to calculate scale?
Diagram over
Nice. Diagram divided by the actual. Okay, so let's do that. Stop if you have a problem with what I'm doing. Somebody tell me what's wrong.
Well, I mean, we're doing it like, we're like reversing it now almost.
We're getting bigger, right?
Yeah.
Yeah, so it's opposite scale. Okay, so it's enlarging. But even when we were reducing it, what was one thing that we had to be certain was the same?
Oh, like our units?
Yes, absolutely, our unit.
But you could convert that to make it the same.
Exactly what we will do. Yep, you bet. I'm gonna go. What did I do here? Millimeters. Yeah. Either way, you just have to make sure that you get millimeters on the top and centimeters on the bottom, right? Because you want your millimeters to cancel, and you want your centimeters to cancel.
Yeah.
Okay. Unit conversions are really helpful. Okay. This is why we show our units when we do this stuff. Okay.
Yep.
Okay. So we're gonna multiply this. How many millimeters are in 1 centimeter?
Let me figure that out.
No, you can't figure that. Are you? Yeah, it's 10. Yeah, good.
It's 10.
Right? Meter stick. Right? The lines in between a centimeter is a meter. Right? So what's gonna happen to our millimeters?
Cancel.
Anything divided by itself?
1.
Thank you. Centimeters cancel. And then we get.
So we have, for every 3.5 centimeters, we have 8.75 millimeters. Oh wait, what?
Okay, so just be careful with your brackets, right? So you're gonna want to do that a bracket, multiply it by 10, and then you should just get 140 over 1, right?
Oh yeah.
Right?
Mm-hmm.
So 140 to 1 is our scale. How would I write this as a ratio?
140 to 1.
Yeah, good.
That could be lower.
So what does this tell me? The scale, 140 to 1.
That it's 140 times bigger. The picture's 140 times bigger than actual size.
Yeah, excellent, good. Really good. Really good.
What? Is this one of the last units?
We're getting there.
So we only have, what? 19.
12 days left.
Oh,
Yeah.
12
We should have a final. We should have our final on like Sunday, March or May or June 20th,
June 20th. Okay, so we're all good there?
and then we'll see how if any of us actually manage to pass the final. 'Cause that's the day after Kager.
Yeah.
What do we got here? Okay. Ooh. Ooh, that's fun.
Yeah, we don't
We
need
can't. We don't really have time. We have like 10.
Not
No, I know. I just didn't know what was in here.
Let's do it all week Monday.
Okay, so remember scale factor is just another way of saying what you will multiply each dimension by, right? So,
Yeah.
yeah, it's just like a condensed version of that thing though, right?
Yeah.
Yeah, so that is like a pretty accurate scale representation of Canada. That globe, this is a pretty accurate actually, no, it's not. Maps have been like incorrect. Okay, I'm gonna finish off this lesson before I get talking about maps. Bye.